From Far From Shore by Sophie Webb. My name is Sophie. I work as a field biologist and naturalist specializing in birds. Tomorrow I am going on a 4-month journey to the Eastern Tropical Pacific Ocean, ETP, to study seabirds and marine mammals. I work for the Southwest Fisheries Science Center, a research laboratory run by the National Oceanic and Atmospheric Administration, NOAA, in California. The cruise's main goal is to discover what has happened to dolphin populations that have been affected by the tuna purse seine fishery. However, we will also observe and count all other marine mammals that we encounter, count the seabirds, my main job, make oceanographic measurements, and study flying fish and squid. As scientists, we want to understand the ecosystem as a whole, not only one part. The ETP, where we will work, is a huge portion of the Pacific, the world's largest ocean. It extends south from California to Peru and west to Hawaii, an area of 7.7 million square miles, larger than the continent of Africa. The open ocean, far from land, can seem lonely and empty, yet there are areas in the ETP that are full of amazing wildlife. Because it is so difficult to study these deep-sea animals far from shore, little is known about their natural history and ecology. My shipmates and I are about to embark on an incredible opportunity to explore this complex and exciting ecosystem. July, San Diego, California. 32 degrees, 73 minutes, north latitude. 117 degrees, 17 minutes, west longitude. I drive south from my home in Central California to San Diego. There I spend several days helping load scientific equipment aboard the NOAA ship MacArthur II and set up our work areas. Over the flying bridge, the highest deck on the ship's crew has strung a canvas canopy to provide shade. We will be grateful for the shade as we head south into the sunny tropics. We've installed 4 sets of big eyes, which will be key to our observations. We use these enormous mounted binoculars with a 25 power magnification to scan to the horizon for marine mammals or count distant bird flocks. 3 computer stations with chairs are also set up. 2 stations, 1 per side, are where we birders sit to collect our bird data. The 3rd one in the middle is where the marine mammal data recorder sits. There are 37 people on the ship. 15 are scientists, 1 chief scientist, 6 marine mammal observers, 2 birders, one of them is me, 2 oceanographers, and 4 visiting scientists. The remaining 22 aboard include the captain, cooks, engineers, a variety of NOAA officers, who navigate and drive the ship, and the deck department folks, who clean and paint the ship and help us collect our data by driving the small boats and running the cranes and winches for casting nets and other equipment. I have worked with many of the scientists before and know most of the ship's crew well. I've spent almost 2 of the past 4 years living and working on the MacArthur II, so the first few days are always fun, catching up with others and learning what they have been doing over the months since the last trip. Although over the next months we will collect data on many aspects of the marine ecosystem, the primary focus of the trip is to find out what is happening to the populations of spotted and spinner dolphins. The dry lab where the computers are located. There is a wet lab as well, with 2 large sinks, one with fresh water, the other with salt water, where the samples from net tows and other scientific activities are processed. Why do we want to know about spotted and spinner dolphin numbers? There are several threats to these animals. The primary one used to be the yellowfin tuna fishery. In the ETP, tuna and dolphins are often found in large schools together. Tuna frequently are caught by a method called purse seining. A net is dragged to surround a tuna school, then drawn closed. If there are dolphins with the tuna, they are caught as well. In the past, tens of thousands of dolphins drowned each year in purse seines. This needless loss of life caused a great outcry by the general public and scientists in the 1970s. The result was the formation of the United States Marine Mammal Protection Act, which protects dolphins and other marine mammals in U.S. waters. Now most marine mammals are also protected by international law. A graph showing how the numbers of dolphins killed in the yellowfin tuna purse seine fishery has declined. Currently, scientists closely monitor the tuna fishery. Now most tuna fishermen allow the dolphins to escape before they drown, sometimes with a swimmer in the net to help the dolphins escape. But dolphin populations are not recovering as quickly as predicted, and scientists don't know why. Does capture cause stress that lowers their survival? Or perhaps overfishing and pollution combined with shifts in climate may be affecting the balance of the ocean ecosystem. With long-term monitoring, combined with ecosystem studies, we hope to understand why these populations aren't recovering at a faster rate. A tuna purse seiner hauls in its net. The yellow skiffs round up the tuna and dolphins into the net. As the net is drawn closed, the tuna dive down and the dolphins swim out. A helicopter and a manned crow's nest, a lookout platform at the top of a tall mast, are used to spot distant tuna schools. Bird flocks are often a clue that the fishermen look for. Finally, we are ready to leave San Diego. Before each long journey, there is always a sense of anticipation. What will we see this time? There is, however, a downside to every long trip. I know I will miss my home, family, and friends. Heading south. 15 degrees, 47 minutes north. 120 degrees, 52 minutes west. Over the next days, we move offshore and head south to warm tropical water. Our route takes us south of the Hawaiian Islands. In a few weeks, after a month at sea, we will turn and head north to Hawaii to resupply and fuel the ship. The ocean color has changed since we left San Diego. It is a beautiful clear blue. I look down through the water and it seems as though I can see for miles. Here the water can be much more than a mile deep. It looks nothing like the ocean near shore off California, which often has a murky green or brownish cast to it caused by lots of plankton and algae. The tropical ocean is clearer because it has much less of these. This net, called a bongo because it looks like the drum, is used for catching small fish and plankton. Some creatures frequently caught in a bongo toe are pictured here clockwise. A spotted larval squid, a semi-clear larval octopus, and a krill. Krill are small relatives of shrimp and are an important food for whales and birds. Where there is food, there are animals. In the tropical ocean, animals tend to be found in patches where there is more plankton and algae. Small fish and krill eat the plankton and algae, larger fish and squid eat them, and so on up the food chain to tuna and dolphins. One of the things we want to understand is what causes this patchiness. We combine our marine mammal and seabird observations with measurements of water, plankton, and algae. Every morning an hour before sunrise and every evening an hour after sunset, we collect water samples from the surface down to 1,000 meters to look at the water's nutrients and chlorophyll. These nutrients are the building blocks of the ocean food chain. In the evening, we also deploy nets to determine the amount and types of plankton at different depths. We use dip nets to catch flying fish and squid. All this information helps us have a more complete picture of the ecosystem of the tropical ocean. A graph of a water sample showing measurements of oxygen, temperature, and salinity, salt, in the water from the surface to 1,000 meters, 3,000 feet. As one follows the graph from 1,000 meters to the surface, note the drastic changes at a depth of about 100 meters. Oxygen and temperature increase sharply as the salinity decreases. This is where two different water masses meet and is called the thermocline. A thermocline that is strong and close to the surface, 50 to 100 meters, can indicate a highly productive area where we might find not only a large amount of algae and plankton, but also animals much higher in the food chain, such as tuna and dolphins. Courtesy NOAA SWFSC. At Beaufort Zero, the ocean is glassy calm. One can see for miles. The pink and violet sunrise reflects on the still water. A day offshore. 13 degrees, 13 minutes north. 122 degrees, 47 minutes west. The day dawns clear and calm, absolutely beautiful. The seas are glassy, Beaufort Zero, a nautical scale that assigns numbers based on wind speed and waves. Observations start just after dawn, when there is enough light to see out to the horizon. Everyone is ready on the flying bridge. Cornelia, a German marine mammal biologist, and Ernesto, a Mexican marine mammal biologist, stand on each side of the flying bridge to scan with the big eyes for marine mammals. Jim, an American marine mammal biologist, sits in the middle at the data computer. I sit with handheld binoculars on either the port left or the starboard right side, depending on where I can avoid the sun's glare to scan for birds. It's time to start looking for critters. It is 10 minutes past sunrise and the light is good. We start to travel along a set course, what scientists call a transect. Soon after we start, Cornelia yells, "Dolphins!" All scanning stops and everyone focuses on Cornelia's sighting. She swings the big eyes in the direction of the dolphins. Using her handheld radio, Cornelia calls the captain on the bridge deck below us, where the ship's steering controls are located. "Bridge, flying bridge, we have dolphins," she says. "Please turn 20 degrees to the left, over." The ship turns. Cornelia scans out to the horizon, looking through the big eyes. What Cornelia sees through the big eyes. At first, all we see are several dorsal fins around the log. We approach the dolphins slowly. One brown booby and 4 Nazca boobies rest on a log surrounded by dolphins. Boobies are often seen far out at sea, resting on any available floating object, including ships and sea turtles. What I imagine it looks like below the log. Frequently, rough-toothed dolphins investigate logs, feeding on the fish that hide in the seaweed growing on the log. Many different animals are attracted to the habitat the log creates. Rough-toothed dolphins specialize in eating large fish such as the mahi-mahi. Olive Ridley sea turtle. Pilotfish. Pelagic triggerfish. Mahi-mahi. Finally, we see odd-sloped foreheads and long beaks. They are rough-toothed dolphins. This species is found in many oceans. Although relatively common, little is known of their natural history due to their deep ocean habitat. All creatures that inhabit the deep ocean are difficult to study. The water is so clear, I see subtle markings on the dolphins as they swim by. All dolphins are odontocetes, toothed whales. Odontocetes also include porpoises, the little-known beaked whales, killer whales, and sperm whales. There is a great variation in size from the tiny harbor porpoise that measures 1.2 meters, 4 feet, to the 18.5 meter, 60-foot male sperm whale. Sperm whale. Killer whale, male. Striped dolphin. Harbor porpoise. We complete the rough-toothed dolphin count. There are 12 in the group and no calves, babies. Marine mammal biologists always note the presence or absence of calves and immature animals to gain clues about when and where the dolphins reproduce. We leave the dolphins by their log and continue on our course. The day becomes progressively warmer. The air is still. Everyone is sleepy. The ship drones on along the transect line. We see no more marine mammals now, but birds occasionally fly by, such as the sparrow-sized Galapagos storm petrel. I record birds out to 300 meters, 630 feet, on one side of the ship. Even when there are few birds, I have to stay focused and alert. I don't want to miss any of them in my count. Galapagos storm petrels are found far out at sea feeding on small crustaceans, halobates, the only marine insect, fish, and jellyfish at the ocean surface. They breed on the remote and protected Galapagos Islands, which have few predators. Their populations at the moment appear to be stable. A Galapagos storm petrel.